This presentation will discuss the debate surrounding cross-curricular teaching and learning and whether maths and science should be taught in a cross-curricular way or as discrete subjects. I will outline the cross-curricular approach and its history while also identifying its benefits and drawbacks. Using examples, I will explore how this approach could be used in the classroom when teaching maths and science and how ICT can be used to enhance children's learning. According to Jonathan Barnes, when the skills, knowledge and attitudes of a number of different disciplines are applied to a single experience, problem, question, theme or idea, we are working in a cross-curricular way. Cross-curricular learning establishes links across different subjects, and Barnes argues that it is the most holistic way of learning. Cross-curricular forms of teaching were designed to help children learn about the world, rather than using a strict curriculum where emphasis is placed on the knowledge required. Piaget was a pioneer of the constructivist theory, where humans make meaning and construct their own understanding of the world in relation to their interaction with experiences and ideas. This theory influenced education and allows teachers to view children as individual learners and adopt a child-centred approach. Piaget was a supporter of active learning, arguing that children learn best through doing and actively exploring. Vygotsky looked at the social aspects of learning and observed that learning occurred in similar playful and exploratory contexts to those observed by Piaget. Vygotsky believed understanding was formed and learning was more permanent when the learners thought, spoke and discovered with others. Cross-curricular teaching has been a topic for debate in education for a long time. The Haddo report endorsed the cross-curricular approach, stating that the curriculum of the primary school is thought of in terms of activity and experience rather than knowledge to be acquired. In Bridget Plowden's report, she looked at how each subject was taught separately like in secondary schools and asserted that knowledge does not fall into neatly separate compartments. Due to Vygotsky's research, much educational thought in the 60s and 70s linked group work, mixed ability and even mixed ages with cross-curricular activity. However, the introduction of the national curriculum in 1987 divided the curriculum into distinct subjects. There was less opportunity for cross-curricular teaching and learning like before. 5 years later, the Three Wise Men report by Alexander Rose and Woodhead in 1992 supported the national curriculum by condemning poorly planned topic work that led to superficial learning. In a 2009 report on the primary curriculum, Jim Rose suggested that cross-curricular teaching would be beneficial to schools to solve problems with covering the curriculum. Ofsted and QCA reports argued that some of the most effective learning occurred when connections were made between subjects. Pupils are able to apply the knowledge and skills learnt in one subject to others, therefore reinforcing their learning and increasing their understanding and confidence. According to Hayes, by teaching the curriculum as an integrated whole, pupils' learning is more holistic and artificial barriers separating subjects are removed so that children can make better sense of the world. Cross-curricular work provides opportunities for children to use and apply what they have learned during discrete teaching of subjects to the real-life contexts. It allows for investigations that engage children's imagination and encourage pupils to undertake active inquiry, show initiative, and discuss and debate issues. Rose suggests that this approach to learning enhances children's ability to understand, articulate, and explain ideas through practical application. Barnes supports it as it allows pupils to be motivated and engaged in their own learning. It is stimulating and nurturing creative thinking. Carr argues that this disciplinary approach can help solve problems associated with curriculum coverage because it allows teachers to cover more content in less time. On the other hand, Carr also highlights the disadvantage of an integrated approach. He recognises its potential to blur the distinctions between the knowledge areas in each subject. The child may not know which subject area is being covered at any one time. This blur can be apparent to teachers also, and it is challenging to assess learning and highlight where the gaps are in subject knowledge. Alexander et al. Assert that the complexity of topic work means that problems remain until rigorous planning becomes the norm. Subject coherence can be lost in the attempt to create a grand theme, and key attainment targets, monitoring and assessment can be given little attention and remain weak. If all subjects are linked via a theme, it is not always possible or appropriate to fit some subjects logically within the theme. Jarvis argues that the cross-curricular teaching runs the risk that some skills and concepts within subjects are inadequately covered, and this opens the debate about whether one subject should be dominant and others should be linked, if and only if appropriate. He also claims that cross-curricular teaching leads to organisational issues and makes timetabling very difficult. Barnes emphasises that good cross-curricular work cannot happen without good discrete subject knowledge, therefore discrete subject teaching is still necessary to ensure fundamental learning occurs. Within the cross-curricular debate, science and maths are two subjects that have been described as natural partners, and as Fiercy asserts, at the heart of science is mathematics. Mathematics and science become inextricable. If we reflect on the science curriculum, we will find many areas rely on mathematical understanding. By integrating maths and science, children are more motivated to learn because they are able to understand the relevance of maths in their everyday lives. They are given the opportunity to use this mathematical knowledge and skills through practical application in science. Although the national curriculum is divided into discrete subjects, it does acknowledge that making connections between maths and relevant subjects can develop pupils' mathematical fluency. My first example of how cross-curricular teaching can be used in Key Stage 1 maths and science is through measuring and understanding what is needed for plant growth. Measurement is central to science, and before this lesson, children will have learnt about units of measurement and how to measure in centimetres and millilitres. An organisational issue when it comes to cross-curricular teaching is seating the children. In this instance, I have to make a decision about seating the children in either their maths or their science seats. Rather than seating children in their discrete subject seats, I would sit them in mixed ability, and this way I will ensure progression in learning. This can be seen as an advantage of the cross-curricular approach because children get the chance to interact with different children in the classroom. Children will work on tables of 6 to explore the factors that affect plant growth. They will create 4 conditions for cress. Over 2 to 3 weeks of science lessons, children will measure the height of their plants twice a week, and whichever plant is the tallest at the end of the experiment will determine the appropriate condition needed for plant growth. This involves mathematical knowledge and skills taken from discrete maths lessons about measuring and counting in order to complete the scientific inquiry into plant growth. This is an example of cross-curricular lessons that use practical application of mathematics to a real-life context. Without this maths understanding, children will be unable to draw conclusions and make appropriate scientific inquiries. My second example involves data handling. My science lesson comes from the national curriculum for Year 6, and children will be investigating what happens to our heart rate when humans exercise. I would ensure that prior learning takes place in discrete maths lessons about how to collect, produce and analyse data. They will be working in table groups to create different activities that will make a heart rate go fast. Using data loggers, children will record the heartbeats of one individual after a variety of activities, for example, skipping, running and resting. By choosing the same pupil to complete each activity and have their pulse rate measured, this variable is kept the same and contributes to a fair test. Some children may not understand the need to present information in a graph if the data has already been collected in a table. However, graphs are very important because they show trends and patterns in data. Therefore, practicing presenting information in a graph is a useful skill that can be transferred from discrete maths lessons and to be used to investigate real-life issues. Through this handling of data, this activity enhances children's mathematical fluency and ability to apply mathematical understanding to real life, while at the same time developing their fair testing and inquiry skills. The use of data loggers also enhances children's ICT skills and supports learning by producing data accurately and efficiently. According to Rose, ICT is a creative tool for communication that can be used in all subjects to discover information and to create, improve and present work. It enhances children's learning experience and provides opportunities for teachers and pupils to access rich and varied source materials. A data logger is able to collect data over long periods of time, manipulate variables and observe cause and effect. This technology allows children to access data quickly. The immediacy, accuracy and ease of measurements from ICT tools provide children with reliable readings, and this enables children to concentrate on the interpretation of their findings rather than the mechanics of taking the measurements. ICT can improve the accuracy and presentation of work when it is used to create spreadsheets to interpret results and evaluate scientific evidence. Nevertheless, it is important that technology does not take over learning in the classroom. Children need to understand concepts in real-life contexts by experiencing it and having a go for themselves. Interactive scale features can be highly beneficial when teaching measurement. However, if children do not have the opportunity to actively use these tools for themselves, they can lack knowledge of what different measurements actually represent. In conclusion, the debate surrounding cross-curricular teaching and learning is one that will always be part of education. Although I acknowledge the risks that come with cross-curricular approaches, for example planning and assessment issues, I would argue in favour of cross-curricular teaching. After researching this approach in relation to maths and science, I claim that children would benefit more so from cross-curricular teaching, because making links within learning is highly important as it allows children to acquire knowledge and skills and practice applying them to real-life concepts. In 1956, Dr. Benjamin Bloom created Bloom's taxonomy to promote forms of thinking in education. This hierarchy is a useful structure to use in cross-curricular teaching because planning for this approach can include all 6 levels of learning. This will allow children to reach the deepest level of learning by evaluating and explaining why something might be based on what they have learned. ICT can enhance children's learning because it provides ample opportunities for teachers and pupils to learn more and experience a more advanced education. It consolidates their knowledge and understanding, especially in abstract ideas. Overall, the links between science and maths discussed in this presentation have highlighted the potential for the cross-curricular approach. Although discrete teaching is fundamental and necessary for basic skills and understanding to be established, cross-curricular teaching with the use of ICT would enhance learning and improve children's practical application and embed their knowledge at a deeper level of learning.